Hello and welcome back. In the last session, we discussed about your Git tags. Now, tags can be used when you want to create a specific point in your commit history and you want to mark it as a release version like version 1.0, version 2.0, and then so on. So, you have made a commit and now you want that commit to be released as a version. You can make use of your Git tags. Now, in today's session, we are putting on our detective hats. We are going to learn how to solve two of the most common mysteries in software development. Who wrote this line of code? And most importantly, why does this line of code break everything? The tool for our investigations are Git Blame and Git Bisect. Let's call it debugging and code archaeology. Now, let's start with the simpler tool, which is the Git Blame. Now, don't let the name offend you. It's not about assigning the blame in a negative way. It's about ownership and context. Imagine you have just opened a file. So let's say I will open this index.html file and you find a confusing line or a strange bug. Your first question is probably, who can I ask about this? Git blame answers that. The syntax is dead simple. You just run git blame and then the name of the file. Let's try it on a file on this index.html file or any file that you want. So the command would be git blame and let's say index.html file. See that? Instantly, I can see everyone who has made changes to this particular file. In my case, I have been working, but if this file is shared by multiple people, you should be able to see everyone's name over here along with the commit ID and then your commit message as well. So this is incredibly powerful for tracking down who to talk to, but we can go deeper. What if I want to see what that specific commit was about? Like for example, let's say this particular commit. I can take that commit hash from the blame and run this git show and then the commit ID. This will show me the full commit, the difference, the commit message, everything. Maybe my commit message in this case, you can see merge branch. So basically we have done a merge. Now I have the full story of this particular commit. So likewise, at any point, if you want to see, as to what all commits has been made on a particular file, and maybe you want to understand whom to reach out to for a particular change, you can make use of your git blame. You can run this command on any file. So let's say now we will try this command on another file, so maybe on this file, and there's only one commit and you can see who committed it, when this was done, what is the message, everything will be available for you. So that is the purpose of your git blame. At any point, if you want to uh, uh, understand as to why a particular piece of code is done and whom to reach out to, you can make use of your git blame command. Now, if the file has been moved or refactored a lot, you can use the -c flag. This will try to track pieces of code back to its original file, which is pure magic for code archaeology. So here you can also try this git blame -c and then let's say profile.html, and this will basically track down your piece of code and back to the original file. So git blame is your first responder. It gives you immediate line by line historical context. Now for the next command, which is your git bisect, this is your tool when a bug appears, but you have no idea which commit caused it. You just know that the main is broken now, but it worked fine 100 commits ago. Now, manually checking each commit would be a nightmare. Git Bisect automates a binary search through your commit history to find the exact bad commit incredibly fast. The process has a few steps. So first, you will need to start the bisect session. You will need to mark a known good commit, basically a commit where things were working properly, and then mark a known bad commit, which is usually the head where things are broken. And then you'll need to help Git test. So Git will check out a commit in the middle and you tell if that commit is good or bad. And then you will need to repeat this until Git finds the culprit. So let's walk through this. Let's say our bug is that in the index.html file, maybe let's say this profile button is not working as expected. So first we will need to start the session. So we will run this git bisect start, and you can see here status waiting for both good and bad commits. So we will need to first mark the current commit as your bad commit is your head. So we'll say this git bisect bad head, and now we will need to specify the old commits as good. So you can use either the tag or the hash value. That's totally up to you. So let's say in this case itself we will take this as the commit. It looks like it's the same. So hold on just a moment, let me do something. Let me get, so we will use this as an example since we have multiple commits done over here. So we will use this as an example. So let me start this again. So git bisect start, and then we will say git bisect bad head, and then let's say this is our good commit. So we know that until this commit everything was working good, and after this we are seeing the issue. So let me get this commit id, and we will say git bisect good and then the commit id. Now Git checks out a commit right in the middle of that history. My terminal now says something like this: bisecting, 7 versions left to test. After this, roughly 3 steps. So basically it's telling me that it only takes about 3 steps to find the bug. Now I need to test the code at this commit. I might run my test suite a specific script or just manually check the application. Once I have tested, I will tell Git the result if the bug is present at this commit or not. So let's say this is working fine. So I'll say git bisect good. Then it will move on to the next commit, and again I will have to repeat the process. I will take this commit and I will test out the change from this commit to see whether the bug is there or not, and then I will need to tell Git whether this is good or bad. So let's say I will say good. So again it will move on to the next commit, and I will have to repeat the same process. So Git will keep reducing the number of commits left, checking out a new one each time and waiting for me to label it good or bad. And after just a few iterations, I will get to know which commit introduced the bug for me. So let's say in our case, this commit is where I find that the bug is there. So I can say git bisect bad, and this one again I'll say that this is working fine. So I'll say git bisect good, and bingo, Git has found it. So this commit here is basically where we are having the bug. So this is where the bug has appeared. Now I can run the git show command to see exactly what changed. So I can take this and I can say git show, and I should be able to see the changes as to what was introduced. So I can see the difference, understand the mistakes and fix it properly. Maybe the code change was not done properly, or the variable was not set properly. Could be anything. Now I know the exact cause. Finally, you must end the bisect session to return to the tip of your branch. For that, we can run this git bisect reset, and done. So always run git bisect reset when you are done. You can fully automate this. So if you have a script that returns exit code 0 for good and non-zero for bad, you can run the script as well. So to recap, use git blame for quick line level questions about authorship, and use git bisect for hunting down the precise commit that introduced a regression or bug. It's a lifesaver. These tools turn you from someone who just uses Git for saving work into a true code archaeologist, able to dig through history and understand the why behind any piece of code. If you found this video helpful, please hit that like button, subscribe to the channel for more content, and let me know in the comments section if you have any feedback. Thank you for watching, and I will see you in the next video.